Welcome to Study Loop.
So we have two things we have to check to see whether mean value theorem can be applied. The first is it continuous on the closed interval? And the answer to that is yes, it's a polynomial. So it's continuous everywhere. Secondly, is it differentiable on the open interval? And that's yes, again, it's a polynomial. So since it can be applied, we know that there is a C value where the slope of the tangent line equals the slope of the secant line. Now to find the slope of the secant line, you're going to take f of b minus f of a over b minus a. And your a and your b are coming from that interval. So your interval is a to b. So our interval, we need f of b, which is 4, and f of negative 12. So f of 4 is 4 minus 4, or 0. F of negative 12 is 4 minus negative 12, which is 16. So the slope of my secant line is going to be f of b, which is 0, minus f of a, which is 16, over b minus a, over 4 minus negative 12. That gives me a negative 16 over a positive 16. The slope of my secant line is negative 1. Now I need the derivative. The derivative, I can just use a power rule. That's going to give me 0 minus 1. So my derivative is just negative 1. Now, my derivative is a constant, which means, and that makes sense, because if we look at this original function, right, that means the slope of this, if I wrote it in slope-intercept form, is just negative 1. And because it's a linear function, the slope is constant. So your C value is going to be, if we're in this interval negative 12 to 4, it's going to be anywhere in that interval because your slope is constant across it. So there's no way to say I'm going to set my slope of my secant line equal to my slope of my derivative and solve, because anywhere on that line you are going to have a slope of negative 1.